In this presentation, we're going to look at some commonly used mathematical functions that we might implement with R. The first one would be powers and roots. For example, x squared, 1 over x cubed, square root of x, cube root of x, and so on. We're also going to look at logarithms, including the natural logarithm, log to the base e, also denoted as ln of x, and logarithms to other bases, for example, log to the base 2 of x. We're going to look at exponentials and also absolute values as well. Just a few more remarks on powers and roots. We might have positive powers of x, such as x squared, x cubed, and so on. Very straightforward. We might have negative powers of x. So if we have 1 over x cubed, let's say, that's equivalent to x to the power of minus 3. The square root, there is a function for square root, that is equivalent to x to the power of a half, or even 0.5. The nth root of x is equivalent to x to the power of 1 over n. So I'm going to bring up R now, and I have a pre-made data set here. We're just going to have a quick look at the data. So x squared, x chevron 2 is how we would do that. The chevron is on the same key as the number 6. Okay, so x chevron 2, x chevron 3, there we have the cubes and all that. Let's try it out for x chevron 0.5, the square roots. There we have it there, 2.00, the square root of 5, square root of 1, square root of 4. By the way, just to be clear, there is a square root function as well that does the exact same thing. But suppose we want to get the cube roots. 1 divided by 3. So this would give us the cube roots of those numbers there, and even the fourth roots. On my slide, actually, I included x to the power of 1/2, let's say. So I'm going to actually just put an x to the power of minus 1. This gives us the reciprocal. So this is 1 over 4. I'm just going to bring back x. 1 over 4, 1 over 5, 1, and 1 over 16. And we could do that for other numbers there. So 1 over x cubed. It goes off the screen there a bit, but you get the idea. Okay, so that is powers and roots. So the next thing we're going to do is look at logarithms. So the function is simply log of x, and this returns the natural logs of x, 1.38 and so on. This is equivalent to log of x to the base e. If we wanted, for example, log of x to the base 2, we actually just have to additionally specify 2. So there we have it there, and so on. And let's say log to the base 4, and log to the base, let's say 10. Log to the base 2 and log to the base 10 would be sort of very commonly used logs in information theory. Okay, so that is logarithms, both the natural log and log to the base 2 and 4 and so on. What we're going to look at now is exponentials. So I'm going to clear the screen again, bring back x. So the exponential of x simply is, there we have it there. They're quite big numbers, particularly because at the end we have, I'm just going to have exp of 5, let's say, just on its own, because on its own it's actually quite a large number. Exp to the power of 16 is huge. So, well, but comparatively huge. Anyway, so that is the exponential. Finally, we're going to look at the absolute value here. So I'm going to bring up some new numbers here. So absolute value of x, simply return the same numbers. Now, suppose I have some negative numbers here. Absolute value of minus 5, just returns 5. Okay, so the command in that case is abs, absolute value. And that concludes our presentation.